Okay, I think I tried explaining to you guys what factoring was going to be. The whole last packet was about multiplying things out. Here. Okay, the whole last, oh yeah, cheat sheet and calculator is what you can use. If you have one.
Can I just use that comment?
Yes. So the whole last packet was about multiplying things out. This packet is the exact opposite. Having a rough morning. This packet is about you being given the answer, and you have to figure out what was multiplied to get that answer. So that's what factoring is. Factoring is you're going to be given the answer, and you have to figure out what was multiplied to get that. And there's all sorts of different ways to do that, and it's not nearly as bad as it seems like it should be. We'll go through like the different methods and whatever. We're in no hurry. This could take us till the end of the trimester. I don't know. We'll find out. Currently, I didn't write it to the end of the trimester, but I know we don't have another unit after it. So if we do get done with this unit before the end of the trimester, we'll just have other random things to work on that aren't necessarily graded or anything. More like projects or fun things. So however long this takes us is fine. Like, we don't necessarily need to rush any part of it. This goes till the end of the trimester. And you'll kind of notice that the packet itself isn't that big. We didn't get a chance to put worksheets in this packet. So that's why this one seems a little bit smaller. We did this same one. If you still have yours, you can use it again. But otherwise, if you just want to copy this one down, I crossed off the prime numbers up to 100. We did it the opposite last time, but I was feeling kind of lazy, so I just crossed off the prime ones. And I have them written on the whiteboard if that's easier. Bless. I'll scroll it down a little bit so you can see the bottom row. Now we're going to do factoring, like with the numbers, a lot this packet. So we'll start off by going the slow method, and then chances are you'll start figuring out how to do it on your own without writing it out. And if you need to make the trees and things, that's fine, you always can. But there's a good chance you'll kind of figure it out as we go. The way I use this, let's say I am asked to factor 57, and I have no idea if 57 has numbers going into it. I would look up there, and since I see 57, that means 57 can be factored, numbers go into it. If it was a prime number, nothing goes into it. But 57 isn't prime, so that would mean I need to figure out what things go into 57. You guys kind of remember the little tricks to figure out what goes into something? Andy, how do you figure out something? How do you figure out if 2 goes into something? That one should be the easiest one.
Wait, no, wait, you said?
132. No, 136. Does 2 go into that? How come? How do you know? Too long of an answer. I mean, I'm not saying you're wrong, just. Noah? How do we automatically know if 2 goes into something? What? 2. How- Wait. Oh, that's not even what I'm asking. I just want to know if 2 goes into it. I'm not asking what times 2. Does anybody know? Like, it's supposed to be super simple.
If it's even,
Yeah.
It's even.
If it's an even number, 2 goes into it. Like, that should be an automatic. That should be an automatic thing that you guys know by now.
68, that would have been a long time.
68.
Sure, 68 sounds great. If it's an odd number, 2 does not go into it. It's even, 2 does. That's why not a single even number other than 2 is a prime number. Oh boy. Okay, I'm not hopeful on the rest of these then. How do you guys know if 3 goes into something, which is the second most common one? I'll just ask the class since, oh. No, doesn't go into every odd number.
That's not true,
Yeah.
If it's a 6 or a 9. Or a
Nope.
3.
Oh, really? Did you guys never learn these?
No.
Oh my. Might have to teach the elementary teachers how to teach this.
Yes, it should be.
If a number adds up to something that 3 goes into, then 3 goes into it. So if I take, actually, I'll do 57. 57 would be one that you wouldn't be sure of. But if I do 5 plus 7, that gives me 12. 3 goes into 12. That means 3 goes into 57. I don't know how many times, but I know 3 goes into 57. What would that be? Probably 19 or something? Yeah, 3 times 19. Okay, so 2 and 3 are by far the most common ones. And you really only need that for the big numbers. You guys already know if it, no, I'll just stop there. How about 5s? I think that's probably more common. 5s and 0s. 5 goes into anything that ends in a 5 or a 0. How about 10? I'm very worried for you guys. We only had a 2-day weekend.
0.
If it ends in 0, 10 goes into it. All right, so I'm getting the impression that a lot of you will be making these trees for a lot of the problems. If that's the case, that's still fine, it still works. It's gonna go slower. Okay. Down at the bottom of this page, this is what we did in the last packet. We're gonna use it differently though. So 12y cubed. If you make a tree for 12, like, do you want me to remind you how to make the tree? I mean, I certainly can. That was an honest question. Okay? If you make the tree for 12, you will find out that it's 2, 2, and 3. Y cubed, y, and y. 3 y's. So if you essentially made a tree for each one of these 3 things, these would be the 3 answers. And then our goal is to figure out what they have in common. Okay? The only thing they have in common is a 3 and a y. So on the last packet, I believe what we did was just write down what they had in common. This is called the GCF. I'm pretty sure that's the only thing we did before. Okay? Oh, do you want me to show you the tree really quick? Do you know how to do it? Okay, I'll show it to you later then if you want me to. Okay. Okay, in this packet, we're doing factoring. And what we are going to do, this is called factoring with the greatest common factor. We are going to write the GCF in front, and then we're going to write a parentheses and write all of the things that are left over. So on this first term, you've got 2y. Well, that's where you get the 4y squared from. On the second one, the things that are left over are 5 and y, and so that's where the 5y comes from. And then on that last one, the only thing left is a 2, so that 2 is the last item. So this is called factoring with greatest common factor. And then I think the part I didn't say anything about here, but essentially, you kept the signs the same, right? There was a minus, I wrote minus, plus, plus. And then this is called factored. So if you write something as a couple item, 2 or more things multiplied, they call that factored. So since we wrote it with the common thing in the front and then a parentheses, that's called factored. Jackie? What would happen if I multiplied 3y back out? What answer would I get? Oh, you know you're thinking about it. You don't need to think of the answer.
Oh.
That's okay. It would have worked if you did. Like, I'm not saying that. Does anybody know what I should get if I multiply that 3y out? The original problem. Yeah. So this is a way you can check yourself, but you know, whatever. We're just trying to take the answer and figure out what was multiplied to get that answer. Okay, so this is the one that's already done, and then I believe everyone on the next page is not. So we're going to kind of go through and do one of those together to start with. And we've got a lot of room. Okay, I'm sensing from you guys you're going to be doing the trees on a lot of these, right?
Yeah.
So then that's fine. I'll do that in the notes. What I think you will get good at is you may not need to write out the letter portions after a while. Okay, so I'm going to make a tree of 30. You pick any two numbers that multiply to 30. 5 and 6 sounds good. 3 and 10 would have worked. 5 is prime. 6 is not. So I'll break 6 down more. 2 and 3. Both 2 and 3 are prime, so I'm done. Basically, if a number is prime, that branch is stopped. If a number is not prime, you keep going. Okay, so there was 30. 30 is made up of 2, 3, 5, and then I've got a squared b. So I've got a, b. Oh, that was bad b. B. Okay, now I'm going to do 56, which might have some more numbers because it's bigger. 7 and 8 should be the most common. If you can't think of that, I'm pretty sure some of you would do 2 and something. Still works. What would it be, 2 and 28? I was going to put 7 and 8 though. 7 is prime, 8 is not. 2 and 4, 2 is prime, 4 is not. 2 and 2, so I've got a whole bunch of 2's. So 56 is 2227. And then what letters do I have? A, B, 3. So I would have A, B, B, B. Now we want to figure out what do they have in common. Okay, this is right. This is the exact same as what we did before, and that's why I think you'll be a little bit quicker at it. see a 2 in common. Do they have any other numbers in common?
No.
No. 3, 5, 2, 2, 7, nothing in common. Okay? Moa, this problem. I haven't gone over here yet. Okay. Macy? What letters do they have in common? Say what?
Oh, the letters.
Letters. I thought I heard you say 2.
A and B,
Okay, how many A's?
2 A's, 3 A's.
So this one only has, in common, not like counting them up. So they each only have a single one. That one doesn't have 2 of them, so they only have 1 in common. And then how about the B's? How many do they have in common? 1. Okay. Over here on the left, sorry, there you go. Over here on the left, I'm going to write down the things they had in common first. 2, A, and B. And then I'm going to write a parentheses. The items they did not have in common are what get written in the parentheses. So this is 15A. I mean, if you multiply them back out if they're numbers. Okay, so I've got a plus. The second one has a whole bunch of numbers. I've got 4, 7, 28. 28, oh weird, 28B squared. And 100% ask if you're not sure where I got the 28 or something from. Otherwise, this would be called factored. And that's what we're trying to get it to be. How's that feel? Is that, I mean, it's not a quick process. Once you figure out the process, it's not hard, but it takes a little while to get that down. Do you feel like you could do the next one on your own yet, or should we do that together still, probably? Together, will do. Okay. Robbie? Help me with 74 and 27.
Five numbers. 27 and 74.
Yeah, so we'll break them down. 74 is definitely on that sheet of numbers on the previous ones. That means something goes into it. It's even, so even if you're not sure of a bigger number, you know, like, so what can you take out of 74 no matter what? 2. And then maybe you need to divide on a calculator or something, I don't know. Would it be 37? Oh, 37, I believe was prime.
Yeah, it is.
Yeah, okay, so that was done. That one feels strange, but that one's done. Okay, 27.
9.
Okay, 3 and 9, whatever order you want to write is fine. 3 is prime, 9 is 3 and 3. Okay, now do you want to keep going, or do you want somebody else to tell me what to write, like underneath?
I think I'll have something else.
Okay, do you want to pick that person?
Lamar, you go.
Okay, Lamar, we've got 2 and 37, and then what letters would I write here? So it's x to the 5th, so how do I write that out?
5 X's.
Perfect. So this is where I think you guys will start figuring out the letters and not need to write them out. Like, over here, I bet some of you are able to look at that and figure out that they have 3 of them in common. You basically pick the smallest number. Over here, we've got 3, 3, 3, Three X's. Okay, Lamar, do you wanna choose somebody for me? What did you pick? Well, he was outside taking a test. I mean, like, he might be able to do it, but still. Well, he was outside while we were doing the notes, so he might be able to do it.
I just picked Mo.
Fair enough, but Mo had already went.
Oh, you did?
I thought so. Thought I called it. Oh. So are you just like going to Jack then, I take it? Oh, I thought for sure you were just kinda like,
Cycle or.
okay. Jack, what do they have in common between the two sets of info? How about numbers? What numbers do they have in common? You don't have to tell them. Nothing. This one has a 2 and a 37. This one has a bunch of 3s. Okay, how about the letters? How many of the X's do they have in common? 3. Hey Jack, can you call in somebody from over here? So it's not just always the same people. I forgot to do that.
Oh, back
Beckett, what do I write on this side? What do I put first?
Put 3 because that's the greatest column
X3. There's no 3. This one doesn't have a 3. So what you're gonna put first is what they have in common. So whatever I underlined in red is what we put first over here. And then they had no numbers in common, so I only write the letters. And then I'm gonna write a parentheses. And then I feel like what you were trying to tell me is what stuff was left, but I could be wrong. How about this first thing? What information is left? Oh, Becca.
That was 14x squared.
Where'd you get 14 from? Oh, got it. Okay, none of the numbers were in common, so I'm actually gonna write 74. And then you were correct with the x squared portion. There were 2 x's left right there. And then on the second half, there were no letters left, but there are numbers only. Should be the 27. So that absolutely can happen. Our goal is just to figure out what things they have in common. It doesn't mean they're always gonna have a lot. Just what things. Oh my, that's a lot bigger. Let's do that one first. That's a lot smaller. I was hoping you guys could try this one. Try this one on your own. I don't know, is there enough room for you to do the trees for all 3 of those numbers? Okay. In a minute, I'll write the correct answer, or like, I'll write the correct tree. Okay. No, that's fine. Oh.
No, 4 is 5. 9 isn't
That's a
lot.
I sent an email home a while ago to parents asking for Kleenex. A lot of people sent them in, so very thankful.
18, right? 18 isn't.
You're only seeing half the problem. The other half is just.
That's even more the way I said it.
That's where all the pencils and Kleenex from.
That's more work that.
Are we supposed to do which one?
This one.
They're both not prime numbers.
You could. I wouldn't.
Look how big the tree is. Except like there's like 12 trees.
Right now, what you get is great.
Christmas tree. Very expensive.
I think I have these correct. Okay. What'd you say? Now I tried to do those on the top of my head, so they may not be correct. So let me know if you guys get the same thing. Well, that's not very big from back here. Can you guys see okay? Okay. 3 and 5. Did you do 4 and 15 for 60? In fact, I just thought everybody do 6 and 10.
Oh, wait, is that like negative or is that positive?
So you can ignore the negative sign for now. We'll get to that later.
Yeah, so he's at work today, so I won't see him.
Did anybody get them done yet?
Yeah, I'm almost there.
6 and 6 and 2.
Actually, I'm not.
You guys get them done, you just don't want to say something? Oh, all right, start from one.
Why are you?
Well, you're actually big.
Yep.
Never say that ever again. Well, the unit just started.
What?
I mean, 2 and 7 hours, so right.
You get sick of it. I had to.
No, it's 6 and 6.
Okay.
Just the 4, yeah. The third one doesn't have.
Yeah.
Emma, what did you get in commons?
Which one is this? Sorry, I finished.
I can't hear, Emma. You got what?
I got 4.
You got 4. They each have 2 2s in common. Now, when you guys write down your trees, what you're gonna find is it's helpful to write the answer in number order, because then it's easy to see how many things in common. If you kind of just write them in the order you've got them, it's not wrong, but it can be hard to match up numbers. Okay, how about letters? Correct. That one doesn't have any letters, so they can't have any in common. So I would put 4 in front of a parentheses. The 2 times 2.
9x.
Yep. Squared.
Squared minus 15x minus 18.
Perfect.
I think they have a 3 in common too.
Wait, that can't be right. Yeah. I was just gonna say 9, 15, 18. I 100% missed that they had the 3 in common. Good catch. Good catch. So 4 times 3, we'd have 12 in common. Yeah, yeah. There we go. Emma, your work's, the portion of yours is still correct, right? It'll just be off a little bit. So this is 5x, and then 6. That's better. So you'll know you did it correct if the numbers that are in the parentheses don't have anything that goes into them in common. So like when I started writing the last one, when I started writing 9, 15, and 18, I knew I didn't do it right because I know 3 goes into all of those. So that means I kind of knew I did it not fully correct. Okay, but good, this is factored. How are we, these aren't very fast, obviously, right? How are we feeling on these? Okay? So what I wanted to do was switch to some other problems. So the homework I have for this is on a worksheet, but the printer was not letting me print. So I have it in Schoology. I can also put it up here, like that's not an issue. Just letting you know that you can either do it in Cami or you can just write the answers on paper, like 100%. Yeah, I tried printing it for you guys, just the printer was not working today. I do have it here.
How many questions?
There's a lot on the worksheet, we're not doing the whole worksheet.
What number does it stop at?
We are doing 1 through 10. So I'll scroll down a little bit. There we go. This is the only portion I want you to do today, to get used to it. Now, do you want me to do 1 or 2 of them with you before? Oh, no?
No, it's like a
Oh, okay. All right, that's fine with me. I didn't know if you wanted that. Okay, 1 through 10.
Is there enough